So what's up guys, this is your resident round bottom flask and welcome to the basic concepts of structure and bonding in the context of organic chemistry. So for this topic, I've decided to divide this into a many-part series of video lectures, and this video is the part 1 of that said series. Well, I can't really give a specific number of how many parts this video has since there may be additional topics that I would like to discuss, or I would like to stagger this topic more, depende sa trip ko. So, this video will touch on the first two topics. So first, we will be discussing a brief history of organic chemistry, and then we'll proceed to some of the basic concepts of chemical bonding, specifically Lewis structure. So, organic chemistry is one of the 5 major subdisciplines of chemistry, and this subdiscipline deals with anything about carbon-containing compounds, their structure, properties, composition, reaction, and preparation. Basta kahit ano, basta organic compounds. Now, thus organic compounds encompass, or thus the definition of organic compounds rather encompass all compounds or carbon, and thus studied in organic chemistry. Well, there are some exemptions. So that will include carbon monoxide, carbon dioxide, cyanides, carbonates, and carbides. So the study of these compounds belong to another subdiscipline of chemistry, which is inorganic chemistry, which is a different course that will be tackled hopefully later on in my channel. So a brief history of organic chemistry. So organic chemistry is, well, it's a relatively new field of science in terms of in comparison to other fields of sciences. Well, because during the ancient times, up until the early 1800s, it was the most popular belief. The popular belief is that organic compounds are only exclusively produced by living organisms and can only be derived from living organisms, of parts of those living organisms, and that thought was called the theory of vitalism. Now, Jöns Jacob Berzelius further supported that claim by postulating that organic compounds are made up of carbon and obviously derived from organisms. So, during that time, he made the distinction between organic and inorganic compounds. So basically, organic compounds are made up of carbon, while inorganic compounds are not made up of carbon. Now, 9 years later, the theory of vitalism was starting to become. I believe the theory of vitalism was slowly being disputed by first this discovery of Michel Eugene Chevreul, wherein he separated the components of soap, which is synthetic, and thus led to the discovery of fatty acids, which are we know derived from derived from living organisms. So before I proceed, segue ko lang pala that Jöns Jacob Berzelius did not only made the distinction between organic and inorganic compounds, he also laid down he was also the first to lay down the foundations of the law of definite proportions na nalaman natin during our high school na natutunan natin during our high school chemistry, and it's still applicable until now. So Michel Chevreul also devised the 72-spoke color wheel, which is famously used by the artists for their color combinations or for their art, obviously. And because of his contributions, his name was inscribed on the Eiffel Tower. So yeah, he was alive during the time when the Eiffel Tower was constructed. Then, around 12 years later, this experiment of Frederick Wohler, a German chemist, revolutionized the definition of organic compounds and gave birth to the field of organic chemistry. In his discovery, he successfully synthesized urea, which is an organic compound derived from urine, from inorganic materials in the laboratory. So basically, he used ammonium cyanate. He just heat it up in a vessel, and this is and it produced urea of organic compounds. So this discovery also marked the slow death of the theory of vitalism. So basically, um, theory of vitalism is dead. Long live organic chemistry. So now, yun nga, mula sa discovery ni Wohler, we've already come a long way. Organic chemistry has come a long way from that experiment of Wohler. And now we can, through the revolutions in organic chemistry over the past centuries, centuries, parang, ano tawag dito, parang masyado na siya nag-advance mula sa simpleng urea na yon. So we were now able to synthesize more complex and larger organic compounds. So an example of that is this compound here, which is losartan. If your parents have hypertension or in their senior years, I'm pretty sure familiar sila sa kung ano yung losartan because they take this in order to manage their hypertension. Another one here this is quite recent. This is from a research paper that I read. Which was published 2018. So what they did is that they have a polymer or a polymeric material, which is polyethylene glycol. They tried to incorporate this structure into polyethylene glycol to make a material that is light responsive. So, mangyayari dito, nangyayari sa material na to, kapag inirradiate siya ng UV light, it bends at a certain angle. And in order to return it back to its original state, you irradiate it again with another UV light of ano tawag dito? Of a lower frequency or of lower energy. So, yun nga, pinapakita ko lang I'm just showing you guys how organic chemistry has over the years has made significant contributions not only to the repository of human knowledge but also to the improvement of society in general. So before we proceed to Lewis structures, I would like to discuss very briefly, or rather to review very briefly the structure of the atom. So we know that the atom is composed of the subatomic particles, neutron, proton, and electron. And the highlight of organic chemistry or chemistry in general is this little guy here, because the interactions interactions of this little guy between atoms, molecules, and compounds lay the foundation of chemistry. Chemical reactions and chemical bonds are formed and broken at the same time, This is because there is interactions between the electrons of atoms, or molecules, or compounds. Now, depending on the interaction of these electrons, we will also form different types of bonds. Now, the first type of bond that we can form is what we call as the ionic bond. And we know na ionic bond is formed due to a complete transfer of valence electrons from one atom to the other. So, ang mangyayari, let's have an example here. The reaction between sodium atom and chlorine and elemental chlorine to form your sodium chloride. So, nangyayari dito, sodium will lose an electron to form this what do you call this ion here. And since sodium will lose an electron, so it will become one electron less than its ground state, so therefore this becomes a positively charged ion, or what we call as a cation. Now, what is lost by sodium will be transferred to the chlorine atom, so the chlorine will accept the electron lost by sodium, so it will gain an additional electron. So it will have one electron more than its ground state, and therefore it will become negatively charged and becomes the chloride anion. Now, we know from our basic science that opposite charges attract. So the cation and anion will attract each other, and that holds the compound sodium chloride together. That electrostatic attraction between the cation and the anion, that is actually the foundation of your ionic bond, an electrostatic attraction between cations and anions in a compound. Next is we have a covalent bond, which we will be discussing more deeply compared to ionic bonds, because almost all of organic compounds are made up of covalent bonds. So unlike ionic bonding, covalent bonding is formed by not a complete transfer, but an equal sharing of electrons between atoms. So let's have the water molecule here. Now, the water molecule contains two hydrogen atoms and one oxygen atom. Now, the hydrogen atom will share its single electron to the oxygen atom. So what happened? And at the same time, the oxygen will share one of its valence electrons to the hydrogen atom. So what happens here is that these two electrons that were shared by each other are what comprises the covalent bond. And these electrons are what we call as the bonding electrons. Now, these bonding electrons does not belong exclusively to hydrogen lang or kay oxygen lang, but it belongs to both of them. So, since hydrogen will share one of its electrons to oxygen, when it forms a covalent bond, that electron shared by hydrogen does not belong to hydrogen alone, but now belong to both hydrogen and oxygen. The same thing happens when the oxygen atom shares one of its electrons to the hydrogen atom. That electron will not only belong to oxygen, but will now belong both to hydrogen and oxygen. That's what we mean when we say there is sharing of electrons between atoms in a covalent bond. So how do we represent covalent bonds or covalent compounds or molecular compounds? So the basic way to represent them is through Lewis structure. So in Lewis structure, pinapakita lang dito kung how our atoms are connected each other in a molecular compound. So we have shown how water, carbon dioxide, and nitrogen and molecular nitrogen are connected together, are formed based on their Lewis structure. So we'll explain that one by one. So let's start first with water. Now, if you see in our Lewis structure, the Lewis structure has lines and has dots. So the lines represent the bonds, which is made up of bonding electrons. So that means this line connecting hydrogen and oxygen represents that hydrogen is bonded to oxygen. And the dots represent our non-bonding electrons, or the electrons that do not participate in the bond formation at all. So if they are paired with each other, so we call them as lone pairs. So to summarize the Lewis structure, so one line is equivalent to one bond, which is also equivalent to two bonding electrons. One lone pair is equivalent to two non-bonding electrons. You have to remember that. So let's check carbon dioxide. Now, carbon dioxide, if you see in the structure of carbon dioxide, there are two lines connecting the carbon atom and the oxygen atoms. And that line is what we call as the double bond. Now, this also represents, it doesn't represent, rather, na may dalawang bonds na nakakonect sa between carbon and oxygen sa ating carbon dioxide. It just says that it is made up of a bond, and that bond is of one bond, and that bond is classified as a double bond because since one line is equivalent to two bonding electrons, therefore a double bond is made up of four bonding electrons. So unlike sa hydrogen or sa water na two electrons are only hold the hydrogen and oxygen together in a covalent bond, this one here, four bonding electrons hold this atom and this atom together in a covalent bond. Lastly, let's check on the structure of the nitrogen atom. If you see, or nitrogen atom, sorry, the nitrogen molecule, if you see, there are three lines connecting the two nitrogen atoms, and that is represented by a triple bond. And that triple bond is made up of 6 bonding electrons. So this, what they call this, atoms, when they form compounds, follow this cardinal rule, which is what we call as the octet rule. So basically, when atoms form compounds, they will do anything, may it be gain, lose, or share electrons until they achieve that 8 valence, until they have 8 valence electrons. Now, since carbon, it belongs to group 4a, and group 4a has 4 valence electrons, so it only needs to gain 4 electrons, or at least share 4 electrons with another atom, or share 4 electrons from another atom. So that means in a covalent bond, carbon can form at maximum 4 covalent bonds. So you have to remember that kasi in organic chemistry, you will deal a lot of carbon compounds. Syempre, yun nga yung definition of organic chemistry, diba? That's we study carbon-containing compounds. So how do we draw this Lewis structure? So there are several steps you have to follow on how to do the Lewis structures. You can actually skip those steps if gamay nyo nang mag-draw ng Lewis structure. Pero if you're still practicing on how to draw the Lewis structure, I suggest you do the steps, okay? You follow the steps by the letter. So how do you draw the Lewis structure? The first thing is you need to do is, based on the chemical formula, you get the total number of valence electrons for all atoms based on the chemical formula, and you also have to take account the overall charge of that molecule. Now, if your molecule is a molecular ion or a polyatomic ion, you add 1 valence electron for every negative charge, and subtract 1 electron for every positive charge on top ng total valence electrons na nakuha nyo sa bawat atom. Okay? So let's try a neutral molecule first. So let's have this molecule, this sulfur dichloride. So it has the atom sulfur and chlorine. So, how do we know kung ilan yung valence electrons ng sulfur atom? So we go back to our trusty periodic table. Ayan. So this is from the practice book of GRE. So thank you, GRE, for that. You can actually download this for free. This is for free, ha? Baka nang walang copyright disclaimer, they're actually allowing you to download this for free, okay? So if you have this one here, let's take a look at sulfur. So sulfur is in this group here. Sorry. Si sulfur ay nandito. Nandito sa group na to. Okay? Nandito siya. It's here. So sulfur is in group 16, or on other notations, it's group 6A, okay? And we know that, and based on our periodic trends, group 6A has 6 valence electrons. So, sulfur, sulat natin, sulfur will have 6 valence electrons. Chlorine, tignan natin ulit ang ating trusty periodic table. Chlorine is on group 7A. Sorry. Chlorine is in group 7A or in group 17, and based on periodic trends, dahil nasa group 7A siya, it will have 7 valence electrons. Okay? So, sulat natin na may 7 valence electrons sa dito. But if you have to look back into the chemical formula that there are 2 atoms of chlorine per 1 unit of sulfur dichloride, or per 1 molecule of sulfur dichloride. Therefore, each of these chlorine atoms will have 7 valence electrons. So you multiply this by 2, then you get the total. So 7 times 2, it is 14. So 14 times plus 6 is equals to, you have a total of 20 valence electrons. Since wala siyang charge, wala kang idadagdag o ibabawas sa total number of valence electrons mo. Excuse me. So let's go back. Then let's go here. So then from the after tallying the total valence electrons, you write you identify first the central atom. Then you write the symbol for each atom and connect them using a single line. And that single line represents 1 bond or 2 bonding electrons. So, paano natin malalaman kung alin dyan yung ating central atom? So, you identify the odd one out. So, since it is only composed of 2 elements, so you identify the odd one out. Obviously, this will be the odd one out because it only is 1 atom per 1 molecule of your sulfur dichloride. So that means your chlorine atoms will be bonded to your sulfur dichloride atoms. So mangyayari, susulat natin yung sulfur, tapos we have the chlorine here on the sides. Then you connect them using a single line. So you connect the central atom to the other atoms using a single line, and that single line is already equivalent to 2 bonding electrons. Okay? After nyan, kung ano yung ginamit nating electrons dito, ibabawas natin sa ating tally na total valence electron. So, since we used 2 lines, so that is equivalent to 2 times 2 bonding electrons, we subtract 4 bonding electrons. So that means from the 20, we have already used up 4 valence electrons, and that is equal to 16 valence electrons left. Okay? So, yung mga electrons na may it be bonding or non-bonding electrons, kukunin natin siya dito sa ating total number of valence electrons. Okay? Next is, after drawing the bonds, you complete the octets around the atoms bonded to the central atom. So going back sa ating sulfur dichloride, ito na siya. So we have 16 electrons left, di ba? Based sa last tally natin. So you complete the octets around, on the atoms bonded to the central atom. So, kailangan makomplete yung octet ng dalawang chlorine atoms here. So this one, sorry. Oops. Lumampas. So this one here, this one is already a chlorine atom, or rather, this one, not chlorine atom, sorry, this is already 2 electrons for chlorine, so it only needs 6 more to complete the octet. So, and that 6 will be coming from this 16 electrons na natira for this chlorine atom to have a complete octet. Now, this chlorine atom will also need 6 electrons to complete the octet. So dalawang 6, so 12 electrons na yung nagamit natin. And we will subtract that to our total na 16 electrons, which is equal to what do you call this? 4 valence electrons left. So saan natin so dapat when we draw the Lewis structures, you have to use up all of your valence electrons, of all of your total valence electrons. Walang labis, walang kulang. Okay? If your Lewis structure did not use up all of your valence electrons, or if your Lewis structure used up more electrons than your total valence electrons that you have calculated, there must be something wrong with either your Lewis structure or your total number of valence electrons, or both. So, dahil may natira pang 4, so ang gagawin natin dyan is you place any remaining electrons on the central atom. So this one here will be the non-bonding electrons around the sulfur atom. So how do we know if your Lewis structure is correct? So it should meet 2 criteria. So 1, all of the atoms are in complete have complete octets. That means all of the atoms follow the octet rule. And lastly, all valence electrons have been used up. No more, no less. So let's check. So 2, 4, 6, 8. So this is 8 for chlorine. For this chlorine atom, this is also 2, 4, 6, 8. So this is, we count this as 2 valence electrons for chlorine because this bond is shared between sulfur and chlorine. Remember in your definition of covalent bond that when a covalent bond is formed, it does not belong to the bonding electrons does not belong to a single atom, but rather it now belongs to both atoms involved in that covalent bond. So that means ang valence electrons dito ay kay chlorine na din. So that is also 8. This is also 8 valence electrons and 8 valence electrons. So complete octet na. Sulfur will have 1, 2, 3, 4. So kay sulfur din to, so that is also 8 valence electrons. So tama it passes the first criteria. Now for the second criteria, let's count if we have used up all of our valence electrons. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So we have used up all 20 valence electrons for our molecule in drawing the Lewis structure. So tama yung ginawa nating Lewis structure. Yay! So what if so tama na to. So what if you have used up all of your electrons but still you find at least one of the atoms in the Lewis structure having an incomplete octet. If that's the case, you try forming double or triple bonds para magkaroon sila ng complete octet. So let's have an example here. So let's do the first 4 steps. So let's tally. So let's tally our total number of valence electrons. So carbon, as I've mentioned earlier, has 4 valence electrons, and since there are 2 carbon atoms, so that is equal to 8. Then for hydrogen, let's check again our trusty periodic table, and we can see on the upper left portion of the periodic table that hydrogen belongs to group 1A. So that means it has how many? 1 valence electron. So, and since there are 2, muntik na. So, ayan, 1 valence electron, and since there are 4 hydrogen atoms there, so that is equivalent to 4 valence electrons. So total, we have a total of 12 valence electrons, okay? Now, then, step 2, we identify our central atom. Ang problema dyan, dahil sa ating molecule, we don't have an element in the molecule na isang atom lang yung ginamit sa ating compound. Therefore, what we can say is we don't have a single central atom for our Lewis structure. So, paano yan? So, yung mangyayari is you have 2 carbon atoms here together and you surround them with your hydrogen atoms. So how do we form the bonds? How do we draw the lines? So obviously the only way is that you draw a line between the 2 carbon atoms, then you draw a line connecting each of the hydrogen atoms to their respective carbon atoms. So it would look like this. So we have used how many? So this is 2, 4, 6, 8, 10. So we have used 10 valence electrons. Ibabawas natin dito sa 12. And that is equal, we have 2 valence electrons left. So according to step 3, tawag dito. Tama. According to step 3, yung remaining electrons, you complete the octets around the valence electrons. You complete the octets rather are on the atoms connected to the central atom. Now the problem is, can we surround a hydrogen atom can we complete the octet with just 2 electrons? Of course not. But the good thing about it is that since hydrogen is in period 1, and we know that on this group here, hydrogen and helium does not necessarily follow the octet rule because of their small atomic size. They can only house at most 2 electrons. So that is for hydrogen and helium. So that means since hydrogen can house at most 2 electrons, okay na yung bawat hydrogen dito dahil meron na silang 2 valence electrons rather. So ilalagay na lang natin itong 2 electrons sa carbon. And if you follow step 4, we have to place the remaining electrons on the central atom as non-bonding electrons. Ang problema, wala tayong specific na central atom. So paano yan? Technically, we can actually put the remaining 2 electrons on either one of the carbon atoms. So we can put it here. We can also put it here. We can put it here. We can also put it here. Or, pwede din tig-isa sila ng tig-isa sila sa natitirang dalawang electrons. Now, ang tanong, has carbon completed its octet? So let's check. So this carbon atom has 2, 4, 6, 7 valence electrons, and this carbon has 2, 4, 6, 7 valence electrons. So obviously they have not completed the octet. So we then proceed to step 5. In order for them to complete an octet, we can form double or triple bonds as necessary. So that means, since meron siyang isang electron dito at isa pang electron dito, pwede na these electrons can form a covalent bond with each other such that these electrons will now be shared between the two carbon atoms. So you will have actually a double bond. So let's check for carbon. It has now 2, 4, 6, 8 valence electrons, and this carbon has 2, 4, 6, 8 valence electrons. Therefore, ito yung valid na Lewis structure. Okay? Then, lastly, there's another rule for drawing Lewis structure. This is for polyatomic ions. So, if the Lewis structure is if we're drawing the Lewis structure of polyatomic ions, we enclose the Lewis structure in brackets, then place the charge on the upper right hand of the structure outside of the bracket. So let's have an example of a simple polyatomic ion such as your ammonium cation. So let's follow steps 1 to 4. So we have nitrogen and we have hydrogen. Nitrogen, okay, let's check ulit ang ating periodic table. So nitrogen is around here. So nitrogen is in group 5A. That means, based on our periodic trends, so group 5A has 5 valence electrons. So therefore, nitrogen will have 5 valence electrons. Hydrogen, on the other hand, we know that na meron siyang 1 valence electron rather, and since we have 4 hydrogen atoms, we multiply that by 4. So you have a total of 5 plus 4 is equals to 9 valence electrons. However, you have a positive charge here, and based on the rule number 1, we subtract an electron for every unit of positive charge. Since the charge of ammonium ion is positive 1, so we just subtract 1 electron here, and the total number of valence electrons will be 8 valence electrons. Okay? Then we identify our central atom and surround the chemical symbol of that central atom with that of the other atoms. So obviously, central atom natin si nitrogen. Tapos papalibutan siya ng hydrogen. Then we connect them with single bonds. Okay? Then we check, since a single bond is equivalent to 2 bonding electrons, and we have 1, 2, 3, 4 single bonds, so we have already used up 8 valence electrons. That means we have 0 electrons left na ilalagay both sa central atom at sa atoms bonded to the central atom. So the only thing that we can do is if we check if it satisfies the rules na it has a complete octet, the other rule that if it satisfies the complete octet. Okay? So obviously hydrogen, since dalawang electrons lang yung kaya niyang ang kaya niyang accommodate, so this is okay na. So, kasi each hydrogen already has 2 valence electrons. Now for the nitrogen, so it should follow the octet rule. So nitrogen has 2, 4, 6, 8 valence electrons. Therefore, nitrogen satisfies the octet rule. Okay na siya. So tama yung structure natin. So we enclose them in brackets. Then, since it has a charge of positive 1, ilalagay natin siya dyan sa upper right-hand corner. So this will be, sulat ko lang ulit. So yung final Lewis structure ng ammonia will be this. Okay? So, thank you guys for watching this video. So shown here are my references. Again, thank you so much for watching this video. There will be more videos to come for this lecture, and don't forget to click the link floating somewhere around above me to subscribe. Okay, so that's it. See you guys.